All right, in this video, we're just going to work on combination circuits and finding the total resistance. The first thing that you have to do, and the most challenging task when you're doing finding the total resistance and working with combination circuits, is finding the most basic components. By that I mean we want to find something that's specifically either series or specifically only parallel. Starting with problem A, you can see that 1 is in series with the 6 ohm. This 1 ohm resistor is in series with that, but that 1 ohm is also in series there. So the most basic component of this particular circuit is not the series component, because you can see that it's in series with two separate things. The simplest part of this circuit is actually right here, the two 6 ohm resistors. They are only in parallel with each other. They're not in parallel with something else. So when I picked that and I said, let's look at the parallel part, I can see it's only in parallel with that one other resistor. That would be different if I said, let's look at just the series part, because again, that series part, it's in series with the 6 ohm resistor and also in series with that other piece. So once you've identified that part, then we're just going to start combining those basic components. And we're just going to use our resistance formulas. So in this case, these are two parallel resistors. So 1 over R, the total resistance, is going to be 1 over 6 plus 1 over 6. That equals 2/6, which equals 1/3. And then I have to flip that over. That's 3 ohms. So the equivalent resistance of that parallel component is 3 ohms. Then I'm just going to repeat. Now that I found the equivalent for that parallel component, now you can see that 1 ohm resistor is in series with the equivalent 3 ohm resistor. So now I can do my next calculation. This is in series, so I'm going to do 3 ohms, or 1 ohm plus 3 ohms. I get a total of a 4 ohm resistor. So that is the resistance of my resistor, or of my combination circuit. Okay, now let's look at B. Again, I'm going to start with part 1, finding the most basic component. So the most basic component, it's either going to be series or parallel, and I can't do parallel first. You can see that this 4 ohm resistor right here, it is in series with, or in parallel with the 3 ohm resistor, but it's also in parallel with the 1 ohm resistor. So I can't use that. Instead, I'm going to start with this series component of my circuit. Sorry. And since those are in series, I will use the series resistance equation where I just add them up. Very convenient. 3 plus 1. I know you guys probably needed me to write that out, but that's 4 ohms. Now that I know this is a 4 ohm equivalent resistance, now that 4 ohm and the other 4 ohm are in parallel with each other, and I can use the parallel resistance equation, which would be 1 over 4 plus 1 over 4. That's going to give me 2/4, which equals 1/2. And remember, I have to flip it over when I'm done. So I get 2 ohms is the equivalent resistance for all of the resistors in that circuit. Okay, so now I'm going to get down to C. C is like excessive and huge. You probably will never see a problem that's this complicated, but it's a good problem for us to kind of cut our teeth and work on solving a combination circuit. So the first thing I'm going to do is identify basic components. A very simple component I could start with is right here. That 5 and 20 are in parallel with each other. So I'm going to do 1 over 5 plus 1 over 20. That's the same thing as 4 over 20 plus 1 over 20. So that works out to be 5 over 20, which is 1/4. And then I have to flip that over. That becomes a 4 ohm resistor. So I can replace that 20 and that 5 with a single 4 ohm resistor. Now I have to figure out where to go next. There's a couple different places. I'm going to combine these ones next. They are just in series with each other. That's a 2 ohm and a 4 ohm. So that's the equivalent of a 6 ohm resistor. Now that I've done that, I can combine this whole parallel part, and I can do 1 over 30 plus 1 over 6, which is the same thing as 1 over 30 plus 5 over 30, which is the same thing as 6 over 30, which is the same thing as 1/5. Flip it over, I get 5 ohms as the equivalent resistance for that one. Now everything's actually in series. I have the 4 ohm, the 1 ohm, the 5 ohm, and the 2 ohm. So that's going to be 4 plus 1 plus 5 plus 2. And it works out that the equivalent resistance, 7, 8, 9, 10, 11, 12, is a 12 ohm equivalent resistance. So that's basically how you find equivalent resistance in combination circuits. If you'd like, I suggest going back to the very beginning of the video and restarting and doing all of these problems on your own. It would be a great way for you to practice, and then you can kind of fast forward and double check your work and make sure that you're on the right track. So thank you for watching. I hope